So what we're going to do in this video is we're going to look at some graphing rational functions. I'm going to do one where I'm going to talk about the process of graphing rational functions, and then I'm going to go and show you how to do it utilizing with a secondary example. So I'm going to start out with f of x equals negative 2x minus 6 over negative x minus 2. Now this is a rational function because we've got a function in the denominator of the fraction. So that's actually really important. So the first thing that I want to kind of get is I'm going to actually take a four-step process to get some really important pieces of this function in place, and then I'm going to go through and I'm going to graph, right? So gather information first, and then go through and do your graphing. So first I'm going to find the x-intercepts, and so that's when y, or when f of x equals 0, okay? So when f of x equals 0. Now, I know negative x minus 2 cannot equal 0, right? So if negative x minus 2 equals 0, then I don't have a solution. So I'm going to keep that in mind. But that also means that when negative 2x minus 6 equals 0, that's going to be the x term of my x-intercept. Okay? Good. So I'm going to solve that. Negative 2x minus 6 equals 0. All right, this gives me that negative 2x equals 6. So x equals negative 3. Okay, so that means that my x-intercept is going to be at negative 3, 0. Notice I wrote it as a point because an intercept is a point, and so we want to describe it as such. Next, I'm going to find the y-intercepts. Well, that one's actually a little bit easier. That's when x is equal to 0. So that's going to be f of 0, which equals negative 2 times 0 minus 6 over negative 0 minus 2, which equals negative 6 over negative 2, which equals 3. So my y-intercept now is going to equal 0, 3. Great. Okay, those are 2 points that are on the graph. And the reason why we did both of those, one, because they're just in general important aspects of any kind of function, and two, they're going to give us some kind of way to make our graph look a little bit more accurate. Okay, great. Next up, find the vertical asymptotes. So the vertical asymptotes are, they are vertical lines where the function is undefined. And for rational functions, that's basically where the denominator equals 0. So in this case, we've got negative x minus 2 equal to 0 is going to be where negative x equals 2 or where x equals negative 2. And this is going to be the vertical asymptote, x equals negative 2. Okay. Sometimes you might have 1, sometimes you might have 2, you could have 3, 4, it just depends upon the actual rational function. For the purposes of our exam, you're only going to have maximum of 2 vertical asymptotes. Now, what about finding horizontal asymptotes? Well, in a horizontal asymptote, let's take a look. We're going to analyze this function. F of x equals, right, negative 2x minus 6 over negative x minus 2. A horizontal asymptote has to do with what happens as x goes to infinity, right? In calculus, we'll end up calling that at the as x approaches the limit of infinity. But the easy way to think about this is that you take the highest degree, okay, of the polynomial, if the top and bottom have the same degree. If the top and bottom have the same degree, then it's going to end up being the coefficient of the top divided by the coefficient of the bottom. So it'll be negative 2 in this case divided by negative 1, which equals 2. All right, so my horizontal asymptote is going to be a y value. It'll be y will equal 2. And what you can kind of get is that as x gets really big, okay, on the top and bottom it's going to get big kind of at an equal pace. And so consequently, all that's going to matter is the coefficient in front of the x term and the coefficient in front of the x term on the bottom. And that's going to end up giving me my y-intercept, y equals 2. Okay. All right, a couple things that I want to get. So the first one, I'm going to go back up to this vertical asymptote, and I'm going to ask myself, as x gets close to negative 2, is f of x positive or negative? And the reason why I'm going to show you why that's going to be in the case, but let's just take a look at the function. Okay, we've got the function right down here. Yes, so my function, remember, f of x equal to negative 2x minus 6 over negative x minus 2. All right, so as we get close to negative 2, okay, let's start from the negative side, okay? Like if I take negative 3. So negative 3, okay, we'll give it an example. Negative 2 times negative 3 minus 6 over negative 3 minus 2, okay? All I want to get is that this is going to be 6 minus 6. It's going to end up being 0. Oop. I don't want negative 3. Sorry. Let's actually go with negative 2.5. So negative 2.5, okay, times negative 2 minus 6, and then negative 2.5 minus 2, okay? So when I do that, the top part is going to be a negative, and the bottom part is going to be positive, right? Which is going to give me an overall a negative, okay? So going towards negative 2 from the negative is going to end up being negative. What about from the positive? So let's take, for example, let's select now, in this case, let's select number 4. Okay? From the positive, and I'll show you why we do this in just a moment. From the positive, we're going to get negative 2 times 4, okay, minus 6 over negative 4 minus 2. And that's going to be a negative over a negative, and so that's going to end up being positive. Okay? So that's just something to get. That from the positive side, we're going to get a positive value of the vertical asymptote, and from the negative side, we're going to end up getting a negative. Okay, just something important to remember. Excuse me. Now we're going to go through and we're going to draw a graph. So the first thing that I want to do is I'm going to put in that x equals negative 2. So there's my vertical asymptote. X equals negative 2. There it goes. And then I have a horizontal asymptote of x equals 2. So vertical asymptote x equals 2. Horizontal asymptote y equals 2. Okay. Then I'm going to put in my y-intercept and my x-intercept. My x-intercept is negative 3, 0. 3, 0. So there's that. There's my x-intercept. My y-intercept is going to end up equaling 0, 3. There's that one. Okay. And then if you remember, from the positive side, okay, one of the things that we did here was that when we're coming down from the negative side, we ended up at negative. So that means that we're going to start at positive up here by the horizontal asymptote, and then we're going to go through negative 3, 0, and then we're going to end up going down towards the negative side as we get close to x equals -2. Okay? Then, if you notice, on the positive side, we're going to get a positive value. So that means that when we're close to -2 on the positive side, right, because over here is the positive side, okay, that means that we're going to go up into the positive areas and then down towards our horizontal asymptote down towards 2, okay? And that's the graph, right? Notice the things that I put in there. I put in a horizontal, I first found the X-intercept, then I found the Y-intercept if it existed, okay? And then I found my vertical asymptote and whether or not it was positive or negative on either side of the vertical asymptote, and then I found my horizontal asymptote. And so consequently, that allows me to go in and draw my graph. And there's my graph.